For the given equation, 3a plus 4b goes to 2c, we are given that 5 grams of A reacts with 10 grams of B. We also have the respective molar masses given. So for part X, we are asked how many grams of C are formed, and for part Y, how much of the excess reactant remains. This is basically a theoretical yield and a limiting reactant problem. So the general basis for this type of equation can be solved pretty much systematically through like a roadmap. Though the process stays pretty much the same, you shouldn't really memorize it, but rather understand the process. So basically, if we have grams of A, we can go to moles of A to their molar mass. And from moles of A to moles of C, we can use the stoichiometry coefficient ratios. And from moles of C to grams of C, we can use the molar mass of C. The process pretty much stays the same for B, but the only thing that changes are the respective molar masses as well as the coefficient ratios. So like I said, you don't really have to memorize this, but it's just a roadmap if you have trouble understanding it. Okay, so now back to the question. Okay, so to find how many grams of C are formed, we can basically follow the road of the roadmap. So if 5 grams of A initially reacts, we can go from grams of A to moles of A to the molar mass. So we're given here of the molar mass of A. So it's roughly 16 grams and 1 mole of A. So A cancels out here. And then to get from moles of A to moles of C, we use the stoichiometry ratios. So for every 3 moles of A, there's 2 moles of C. So we can just put, to cancel out the denominator moles of A, we can put for every 3 moles of A, it's 2 moles of C times. So in order to get from moles of C to grams of C, we just have to use the molar mass. So this 32 grams and 1 mole of C. I got that from right here. And this gives us roughly 6.6 grams of C. So now, the same thing goes for part B, but like I said before, we have different molar masses and different stoichiometry ratios. So let me use a different color. Okay, so for B, 10 grams of B, and in order to get the moles of B, when you put 1 mole of B reacts with 12 grams of B. So in order to get from moles of B to moles of C, we just have to use the stoichiometry ratios again. So we can see here, for every 4 moles of B, we get 2 moles of C. So 4 moles of B gives off 2 moles of C. And then to find the molar mass, it's given right here. So it's 1 mole of C gives off 32 grams. And that is 13.3 grams of C. So as we can see, A has a lower yield than the reactant B. This tells us that this is a limiting reactant, and this is the excess reactant. Okay, so for part Y, it asks how much of the excess reactant remains. And so for part X, we know that the limiting reactant is substance A because it yields off 6.6 grams of C. So essentially, you have to work backwards and see how many grams of B actually react in the reaction. So when you go from grams of C to grams of B, so we have 6.6 grams of C, and to already get moles of C, we just need to use the molar mass. So for every 1 mole of C, there's 32 grams. And then in order to get from moles of C to moles of B, we just use the stoichiometry coefficients. So we see here that for every 2 moles of C, there's 4 moles of B. So we can just put that over here, 2 moles of C and 4 moles of B. And then in order to get from moles of B to grams of B, we use a molar mass. And it's given through here that is approximately 12 grams per 1 mole. So 12 grams of B, 1 mole of B. And so we want to make sure that everything cancels out in the denominator. So grams C cancels out, grams C cancels out, moles of C cancel out, moles of C cancel out, moles of A cancel out, and moles of B, cancel out, and then moles of B cancel out over here. So this gives us 4.95 grams of B actually react in the reaction. And so we initially started off with 10 grams of B, and if only 4.95 grams of B reacted, we can subtract these two amounts to see how much remains. So 10 minus 4.95 equals 5.05 grams of B remains, and that's how much of the excess reactant remains.